Review what you learned in the past lesson by sketching the graph of y equals 2x squared plus 8x plus 6 without a table. Specifically, find the x-intercepts and the vertex of the parabola. One thing I noticed right away is the y-intercept. If those x's were zeros, the only value left in the equation would be a y-intercept at positive 6. I'll put that on my graph, and then we'll start factoring to find the x-intercepts. Now I try to factor. We need to pick two numbers that are going to multiply to 12x squared and add to 8x. So that would be 2x and 6x. So put those into our problem. 2x, 6x. Take out the common factor. There's a 2x here. X here, 6, and 1. So we've got 2x plus 6 and x plus 1. I'm noticing that I missed taking out the greatest common factor before I started factoring. There's still a common factor of 2. That doesn't change my x-intercepts. It doesn't matter that I missed that step. So now we're still going to try to find our x-intercepts by looking at when could each factor have been equal to 0. So x plus 1 is equal to 0. If we minus 1, it's at x equals negative 1. There's one x-intercept. And for my other factor, 2x plus 6 has to equal 0. Minus 6, and divide by 2, so we get x is negative 3. Negative 3 and negative 1. I can kind of start to see this U-shaped parabola that's going to go through my equation. The problem is I don't know the vertex yet, so to find that, we pick the x value that would be in the middle of my two x-intercepts. So in the middle of these x-intercepts is negative 2. So that's my x-coordinate for my vertex point. It's going to be negative 2 comma something. And the way that we find that is we just plug in negative 2 to our equation. So to find the y value, 2, plug in negative 2 as the x, negative 2x squared, plus 8, plug in negative 2, and plus 6. Negative 2 squared is positive 4. Then times 2 would be 8. 8 times 2 is negative 16, and plus 6. And we get negative 2 as our y-coordinate for the vertex. Now this is a lot of work to factor to find the x-intercepts, to then find the middle of the x-intercepts, to plug it in, to finish finding the coordinate of the vertex. How could we do this faster? In the rest of the video, we're going to be working towards something called graphing form or vertex form. Use the zero product property to find the roots, aka x-intercepts, of x squared minus 3x minus 7 for y. So I set up the factoring, and I try to pick numbers that multiply to negative 7. The only things that multiply to 7 are 7 times 1. But 7 and 1, even if I put a negative in there, could never make negative 3. So this is unfactorable. Because it's unfactorable, does that mean it has no x-intercepts? That is a wrong assumption. Unfactorable means it doesn't have whole numbers for x-intercepts. So the x-intercepts are going to be on some random decimal location. So what we would need to do is go onto our graphing calculator, type the equation into the y equals button, and then look at a table of x and y values, and we can scroll through and try to get as close as we can to where the actual x-intercepts are. So in my table, I can see there should be an x-intercept, a 0 position in here between negative 3 and positive 3. On a graphing calculator, if you go second window, it lets you change the table. So I might go down to where it has a triangle table, and that's second window. And then you can set that scale to be 0.1. And that will let you get more accurate in your table. So as I look through my table, I can see right around 4.5 or 4.6, it would get to 0. And there should be a second x-intercept as well. Around negative 1.5, we also get to 0. So they're just decimals. That's why it was unfactorable. The following functions are also quadratic functions. Part A, verify that both equations are quadratic by rewriting them in standard quadratic form. Remember the order of operations. So if I start with this first one, I'm only going to do the first one. We have 3x minus 2 squared minus 5. Now remember, when something is squared, that just means it's multiplied by itself. X minus 2 times another x minus 2. Then we can multiply it by 3, and then we can minus 5. You can use the box to multiply x minus 2 by x minus 2, or you can use that distributive property. I'm not going to show the work, I'm just going to write the answer. It's x squared minus 4x plus 4. Still need to multiply that by 3 and then minus 5. So if I multiply everything by 3, again, distributive property, 3x squared minus 12x plus 12, and then minus the 5. So combine like terms. 3x squared minus 12x plus 7 is our final quadratic equation. Then we can, again, use the table or the graph on our calculator to look at the graph and try to find its x-intercepts and its vertex. And when I looked at the graph on my calculator, or in the table, I found that the x-intercepts were at 0.7 and 3.3, random decimals, but the vertex was at 2, -5, perfect numbers. Now if I compare that back to the original equation, I can see that 2, kind of like an x-intercept, the vertex is at +2, but it said x minus 2 in the equation, because to get to a 0, +2 minus 2 would make 0. And I can see the minus 5 of the vertex is also shown here. So this particular formatting of the equation is called vertex form or graphing form. Just by looking at the equation, you know the coordinates of the vertex. So let's quick go through the other two. Here, in the x minus or x plus 4, in order to get to a 0, the x would have to have been -4. So in our vertex, or that means our highest point or our lowest point of the parabola, the x coordinate would be at -4, comma, and then the number that's added on at the end is not the y-intercept, it's actually the y-coordinate of the vertex. This formatting does not particularly show us the x-intercepts or the y-intercept, just in its format. And if we did one more example, in the equation down here, the x plus 3 tells us that for our vertex, the highest or lowest point on the graph would be at -3, comma, +2. Let's look at how we could use that to help us. A function y equals blah is a quadratic. Let's explore how to draw and sketch of the parabola without making a table. Write the equation in standard form and use the zero product property to find the x-intercepts and vertex. Make a sketch. We are not going to do that. That's a lot of work. I don't want to distribute and combine like terms and then refactor it and find the vertex. I can do all the work from the original format of the equation instead. If I'm looking at that equation, I know right away that the vertex is at -1, because -1 plus 1 would make 0, comma, -16. If I wanted to find the y-intercept, I could plug in 0 for x and calculate what I'd get. But to find the x-intercepts are what happens when the y is 0, or when the equation is equal to a 0. So we're going to do 0 equals x plus 1 squared minus 16. I could do distributive property and refactor it, but that's a lot of work. Instead, I can solve a regular equation. Add 16 on both sides. 16 is x plus 1 squared. I can unsquare this by doing the square root. So x plus 1 and the square root of 16 is 4. And so if I were to minus 1 on both sides, I would know that x equals 3, because 3 plus 1 equals 4. Problem with this is this only looks like I got one x-intercept. There should be 2. So what am I missing? The part that I'm missing is that when something gets squared, even if it was a negative, when it gets squared, it turns positive. So when we square root this, we don't just look at when it could be positive 4, but we also look at what if it had been negative 4. Because when negative 4 gets squared again, it would become positive. This is just like an absolute value problem. You have to solve it twice. Once when you have the positive version and once when you have the negative version. And again, if we minus 1, we would get x equals negative 5 as our other x-intercept. And just to confirm, if I look in the middle of these two x-intercepts, in the middle of negative 5 and positive 3, is exactly 1, negative 1 for my vertex. So in general, if you see an equation like this in graphing form or vertex form, you can always quickly write the vertex, and if you make the equation equal to 0 and solve by getting the x by itself using a square root and getting two answers, one with a positive value and one with a negative value for your square root, you should see both x-intercepts. Let's do a quick reminder of the 3 different forms we've experienced. Standard form looks like y equals ax squared plus bx plus c. And the most important piece of information that you can get from standard form is the y-intercept. Factored form looks like y equals something and something. I'll put a minus there. The most important information you can get from here is the x-intercepts from factored form, because you're looking for those when they could equal 0. And lastly, the graphing form is sometimes a multiplier to make it taller. X minus a value plus a value with a squared. And this tells us the vertex, the h and the k. So this tells us that the vertex is at h, comma, k, the highest point or the lowest point. I would recommend writing this down as notes for yourself.